AI has gotten unbelievably good at talking. It's incredible, but the next big jump, the real game changer, it isn't about having a better conversation. It's about taking action. Today, we're going to unpack this amazing evolution of how AI is learning to stop just talking about the world and start actually doing things in it.
So we've all seen AI master language, right? It can draft an email, write a poem, you name it. But honestly, the real frontier isn't about words anymore. It's about actions. And the huge question for everyone in this space, and for us, trying to understand it, is this. How in the world do you get an AI to do more than just talk?
And that question brings us straight to what the researchers are calling the Agentic AI challenge. This is the whole ballgame. It's all about bridging that gap between an AI that can tell you how to do something and an agentic AI, a true agent that can actually go out and perform a whole series of complex steps to get something done.
Here's the fundamental problem we're up against. For all their wizardry with language, the standard AI models we've been using, well, they pretty much hit a brick wall when things get complicated. They're just not built for tasks that need you to plan ahead, to reason through a problem, or, and this is the big one, to adapt when your first plan goes sideways.
So, how do you fix that? Well, the breakthrough really came from a simple, and let's be honest, a very human idea. What if you teach the AI to just stop and think before it does anything, to make a plan first? And this idea gave birth to a method they call strategy-guided exploration, or SGE for short. It sounds fancy, but it's actually brilliantly simple. Before the AI even tries to click a button or type a word, it first writes out a little plan for itself, just in plain English. It's almost like it's making a little to-do list. Okay, first I'm going to type the file name, then I'll find the menu to change the extension.
And the big idea here is, well, it's pretty profound. It is so much more efficient for an AI to brainstorm a few different plans than it is to just blindly try out thousands of random actions. By thinking about the strategy first, the AI massively increases its chances of finding the right move. It stops just guessing, and it starts actually planning.
And this right here, this visual, says it all. On the left, you've got a standard AI agent trying to change a file extension. You can see from all those little dots it's totally stuck. It's just tapping the same part of the screen again and again and again. But look over on the right. That's the agent using SGE. It's coming up with different strategies, which means it's trying different actions, tapping all over that box until, boom, it finds the drop-down menu. It's a perfect picture of planning versus guessing.
And the numbers, they back this up, big time. That blue line shooting upwards, that's the success rate for an AI using this think-first method. It doesn't just learn faster, its overall success rate is way, way higher than the other approaches. That one simple act of making a plan, it makes a world of difference. And this isn't just about beating the basic models either. Even when you put it up against other really advanced techniques, like this one called GRPO, it's the same story. Look at the charts. Across the board, those blue lines, the SGE planner, they just consistently outperform the others. It's a much more robust and effective way to teach an AI how to solve problems.
Okay, so now our AI can think, it can plan, that's huge. But a plan is pretty useless if you can't actually act on it. So the next major step in this evolution is giving that digital brain a body, a way to really interact with the world.
And this is basically the wiring diagram for the AI's mind and body. Right there in the middle, you've got the cognitive core. That's the brain, the part that's making all the plans we just talked about. And then, that brain uses a robot toolkit, which is basically its hands and feet, to actually go out and do things based on those plans. The whole process works in a really simple four-step loop. It's pretty intuitive. First, you give it a task. Second, the AI comes up with a plan on its internal scratch pad, just like we saw. Third, it executes that plan by picking a tool, like grab this thing or move to that spot. And finally, and this is key, it gets feedback. The system tells it if the action worked or not, which is how it learns and adapts for the very next step.
All right, so we've got an AI that can think and an AI that can act. But let's be real, the most powerful learning for us, and it turns out for AI, happens when we learn from each other. The final critical piece of this whole puzzle is teaching AI how to work and learn together as a team.
Think about it. A single AI, on its own, is always going to be limited by what it was trained on, by its own little bubble of experience. But when you create a system where these AI agents can learn together, wow, their abilities just explode. They can share what they know, weaker models can get coached by stronger ones, and they can even challenge each other to find blind spots and come up with better solutions.
One really fascinating way they're doing this is with something called reference-guided fine-tuning. It's a super clever way to help an AI that's completely stuck on a problem. You don't just give it the answer. No, you give it a little hint, a tiny clue from a solution that worked. And the AI uses that little breadcrumb to figure out the rest of the path on its own. It's basically learning a whole new way to think.
And you can build on this idea to create actual AI teams. There's this other method, HACPO, where you can pair up different AIs that have different strengths. The more capable models act like mentors, They give guidance to the others, they share what they've learned, both what works and what doesn't. So the entire group gets smarter, together. It's literally AI mentorship.
And maybe the most mind-blowing, the most human-like form of learning is debate. The research is showing that, just like with people, the value of an AI debate gets bigger and bigger the more diverse the debaters are. When you have two models with different training, they can poke holes in each other's logic. They can uncover knowledge the other one didn't know it had, and they arrive at conclusions that are way better than what either could have done alone.
So, when we put all these pieces together, the planning, the acting, the collaborating, we start to see a really clear picture of where all of this is going.
We've just walked through the 3 critical stages in the evolution of an AI agent, right? First, it learns to think first, using those internal language strategies. Then it learns to act on the world, connecting its brain to a body and a toolkit. And finally, it learns how to get exponentially smarter by learning together with other AIs.
What we're really witnessing here is a huge shift. It's fundamental. AI is evolving from being just a passive tool into an active, problem-solving collaborator. And that leaves us with one heck of a question to think about. As AI learns to think and to act and to team up, what kind of problems are we finally going to be able to solve together?